In this video, we're going to try to solve the following problem. Given that a and b are real numbers with a and b both strictly positive, we assume that a and b satisfy this condition. The log of a plus b over 3 is equal to the average of the log. That means the log of a plus the log of b over 2. We want to find an expression for a over b. How can we do that? Before proceeding, we can use this fact that we have both a and b are positive, and we have the log, the natural log here. So we can use these properties of the log and try to find something that would help us solve for a over b. One key idea is that here we can transform this sum into product, and we can let this 1/2 enter inside the log. And after that, we know that the log is an increasing function and it's injective. We can use that fact to equate both sides and solve for a over b once we know how to scale b to make it appear in the right side product. If you want to try it yourself, try to stop the video and work it out. So let's solve this one. First, we're going to use this fact here that we have this 1/2. We're going to keep it here, and we're going to transform this fact here, the log of a plus the log of b, as the log of a times b, because both of them are positive, and this is a property of the log when these two are defined positively. Okay, now we'll take this exponent inside. So we have the natural log of the square root of ab. Okay, now since now we have this expression, the natural log of a plus b over 3 is equal to the natural log of the square root of ab. We can equate these two. Okay, because the natural log is an injective function. Okay, so we have, or you can just take the exponential. So have a plus b over 3 is equal to the square root of ab. So now we're gonna appear this b here. So we can divide both sides by b. We get, or let's keep this 1 3 outside. So we have a plus b is equal to the square root of ab. Okay, so here we're gonna divide by b. Since b is strictly positive, we have no problem dividing by it. Also, we have no problem with square root. So we have, so when we divide, we have, let's make this 3 here. Let's do a plus b equals 3 square root of ab. So let's divide by b. So we have a plus b over b equals 3 square root of a b over b. So here we have a over b plus b over b, which is 1, equals 3 square root of a times square root of b over b. Okay, so we can simplify this one as 3 square root of a times 1 over square root of b. Okay, so we can multiply up and down by square root of b, and we're gonna get rid of this b here, and we're gonna keep the square root of b down. So this one gives us, in this case, the following. So we have a over b plus 1 is equal to 3 square root of a over b. Okay, so now to solve for this quantity that we need, we have to get rid of the square root. And since this quantity is positive, we can take care of that by just squaring both sides. So let's make one more change here. Let big X equals a over b. So this equation 1, so 1 becomes x plus 1 equals 3 square root of x. Okay, we can graph these two. Okay, so the equation here, it's going through minus 1, 1. So this is x plus 1, and the square root of 3, since it's scaled by 3, it's gonna jump a bit. So it's gonna go up and go down. So we see that we have two solutions. If we just graph this one by hand, it's not nicely done, but you get the idea. So we see that we have two values for x, and x in our case is a over b. So let's see what we can do here. We can square both sides to get rid of the square root. So we have x plus 1 squared equals 9x. Okay, so this one equals 9x squared plus 2x plus 1. I'm gonna add minus x to both sides. I have minus x, and here I have 0. Now we have this equation, x squared minus 7x plus 1 equals 0. Now we can use the discriminant for the quadratic the quadratic formula to get the x. So I have delta is minus 7 squared minus 4 times 1, which is 49, minus 4, which is 45. So I have my x1 is minus b, that means 7 minus square root of 45 over 2. And I have x2 is 7 plus the square root of 45 over 2. Since a and b both positive, we expect that a over b, so a over b equals 7 minus square root of 45 over 2, or a over b equals 7 plus square root 45 over 2. We will have to check. So here the square root of 45 is less than the square root of 7. The square root of 49, which is 7. So this is positive. This one is positive because it's the sum of two positive numbers. So we have either a over b equals 7 minus square root of 45 over 2, or 7 plus square root of 45 over 2. Both of them are positive, and therefore this is the value that we are looking. These are the two values that we are looking for. This would end our solution.